Hey guys, it's Miss Miller and I want to show you how to graph in Excel, and I'm going to do one of your data sets to show you how to find the relationship between two variables. Here these first two sets have already been typed in for you, so I'm just going to show you how to create the chart in Excel. The first thing you want to do is highlight your data, and we're going to go up here to Insert. And right here under charts, we're going to go to the scatter plot. Now we do not want it to connect our dots at this point. Here we need to add a few things to our chart, so we definitely need a chart title. I'm just going to put height versus the number of stories, because those are our variables. Now the variable on my x-axis here is the number of stories. So I need to add an axis. Let's see. So here in right here, this plus up in the right hand corner, chart elements. Yeah, I want axis title, so I want to check that. I already have a chart title. One thing I want to look at to help me determine my relationship will be the trend line. We're going to look at the trend line, base that off of the function, and then determine the relationship. Now, if you go to trend line and go over here to more options, you can click this right here. These three bars. These three bars will allow us, okay, well, could we do, does this look pretty linear? Well, yeah, it does, but if it didn't, we could try an exponential fit or a logarithmic fit. Now remember, these are all based on those parent functions that we were looking at. But it looks closely to be linear. So we're going to scroll down over here on the right, and this is what's important. It says display equation on the chart. So that's going to help us look at our relationship and the display the R squared value. R squared is called your correlation coefficient. It tells you how closely related or how good your trend line is. If it's close to 1, then it's a very good fit. If it is closer to 0, then you do not have a linear fit at all. I'm going to go ahead and fix these titles. Now my y variable is the height of the building, and when graphing you need to make sure that you put your units here. My units are meters. And this axis title is the number of stories, and of course the unit that we would be talking about here would be stories, so I don't have to add anything in parentheses there. If for some reason something messed up and you had your independent variable and dependent variable backwards for some reason, you can change your data. Let's see, how do we do that? Not chart elements. I think we're going to go up here to design. Okay, right here, switch row and column. I think that will allow us to change our data. No. Okay, so actually if you just come up here to design under chart tools and go to select data, it's not switch column and row, it is actually edit, and then you can go in and edit your x values and your y values just to make sure that you have what you need. So this says 21, 35, 16 is currently my x values, and that's incorrect because the number of stories needs to be my x values. So I'm going to go right here and highlight that. And now it's fixed that. And for my y values, I need it to be the height of the building. So you can see it says 21, 35, 16. Alright, and then click OK, and here is your relationship. This is your trend line. If I were to ask you what is the relationship, because that's going to be an important question for this unit, between the height of the building and the number of stories, you would say, well, looking at this trend line, that is a linear function, and we say that's proportional. So your answer should be worded something like this. The height of the building is proportional. Let's say directly proportional, because it's a direct relationship, to the number of stories. That would be your answer, not well, as one goes up, the other goes up. That wording is not scientific. The relationship is directly proportional. That's what I'm looking for. Now, let's talk about this equation. Y equals 2.7336, x plus 1.918. We need to talk about what those variables might mean. Well, if I wanted to write a literal equation for this, my y variable is the height. So it should actually be height equals 2.7336. X, my x variable, is the number of stories plus 1.918. This should make a lot more sense. So this is saying that if I wanted to know the height of the building, I multiply this number by the number of the stories and then add this 1.9. So this 1.9, or approximately 2 meters, is saying no building is going to be below 2 meters, and that makes sense. Okay, it's going to have some height if it's a building. Now, if we have a 2-story building and I wanted to know the height, I would just say, and then here I'm just going to do a quick equation. I would say 2.7336 times 2, the number of buildings that I'm trying to find. Again, this is a model we're using to now be able to predict the height of any building based on this model. So let's say instead of 9 stories or 12 stories, we want to say, okay, well, what is the height of a 40-story building going to look like? We found a typo. Okay, so it said I needed to put the star in here to multiply that. Yes, I want to accept that. Okay, well, the height of a 2-story building is going to be 7.4 meters. And remember, a meter is about 3 feet, so that's going to be about 21 feet for a 2-story building. Okay, let's look at the second example. I'm going to add another chart. Actually, I want to move this data down a little bit. Okay, let's go ahead and add another chart here. So, insert. This one should be much easier now that we know what we're doing. Chart, scatter plot. Okay, this, isn't as good of a relationship as before. Let's see if we can bring it down here. Okay, it's not quite as pretty as before, but we can still make do. It still looks pretty linear. Let's change our chart title. What are our variables? Number of classes offered and the number of students taking the classes. So let's just say school trends. That's what we're looking at, so I'm going to name that. To format my chart, I need to, or to design my chart, I want to add different elements. So I need to go to this plus, and I want my axis titles. I also want a trend line. My y-axis should be number of students. So I'm going to type in number of students here. This should be the number of classes offered, essentially. So number of classes is going to go here. I also want to look at my trend line closer. So we're going to go to right here, trend line. We're going to go down here to more options. Go over here, click the bars, and it is a linear regression, a linear trend. I want to display the equation and display the R-squared value or correlation value. Now, to answer my question, if I were to ask you what's the relationship between these two, your answer should be the number of students is directly proportional to the number of classes offered. And that makes sense. If you offer more classes, then more students are going to take those classes. The literal equation should look something like this. So, number of students equals 32.432 times the number of classes plus 1.267. So this is the model that we have created. Now we can estimate, okay, well, if this university or something offers 12 science classes, that's a lot, but how many students are we going to have taking those classes? Alright, and that's long enough for this video. We will look at the other graphing video somewhere else. So practice playing around with Excel and graphing this data here. Make sure that you understand how to create graphs in Excel and get your trend lines. Thank you.